Step outside right now, feel that warmth on your face. That soft, familiar sunlight you've known your entire life. It's destroying itself. Right this second, as you're watching this, the sun is detonating, not burning. Burning is a candle. This is something else entirely. Every single second, it vaporizes 4 million tons of its own mass, gone, turned into pure energy. And it's been doing that, without pause, without rest, without stopping, for 4.5 billion years. Take every nuclear weapon ever built, every warhead, every Cold War bomb, every test in the Pacific. Set them all off at once. You wouldn't even come close. The sun does more than that, every second. Before you finish this sentence, and yet, here we are, 93 million miles away, sitting on beaches, growing gardens, smiling when it peeks through the clouds. We treat it like a friend. But what we're actually looking at is the most violent nuclear explosion anywhere near us in the entire universe. So how are we still here? What's standing between us and a force that should have erased this planet a long, long time ago? The answer is one of the most beautiful things in all of physics. Something invisible, something delicate, something holding this entire situation together by a thread. And once you see it, I promise you, you will never look at the sky the same way again. But before we can talk about what's holding the sun back, we have to talk about what it actually is. Because you can't appreciate the force keeping a monster in chains until you've looked the monster in the eye. So come with me, just for a minute. Forget everything you think you know about that bright thing in the sky. We're going to get closer to it than any human being has ever been. Picture this. If you could somehow shrink yourself down, climb into a tiny spaceship and fly straight toward the sun, the first thing you'd notice isn't the heat, it's the silence. Space is quiet. Eerily quiet. No wind, no sound. Just you, your ship, and that glowing ball getting closer and closer, and then something starts to happen. That soft yellow glow you've seen your whole life. The one you've squinted at on summer afternoons. The one that's been rising over your backyard every morning since the day you were born. It starts to change. It gets brighter, then whiter, then so blindingly intense that if you looked at it with your own eyes, you'd go blind in a fraction of a second. Keep going. Keep flying. Eventually, if your ship could somehow survive the impossible, you'd punch through the outer layers of the sun and descend toward its very heart. And what you'd find there is something that almost sounds made up. You'd find a place where the temperature is around 27 million degrees Fahrenheit. Let that number sit with you. Not 27,000, not 2,700,000. 27 million. Hotter than anything you've ever experienced, anything you've ever seen, anything you've ever imagined. And the pressure? A single teaspoon of material from the sun's core would weigh more than a car. Not a small car, a full-sized American sedan, sitting on a spoon. In that impossibly dense, impossibly hot furnace at the center of our star, something extraordinary is happening. Hydrogen atoms, the lightest, simplest atoms in the entire universe, are being squeezed so violently together that they're literally fusing into each other. 4 hydrogen nuclei smash together. When they do, they form one helium nucleus. Sounds simple enough, but here's the part that genuinely stopped scientists in their tracks when they first figured it out. The helium that comes out weighs just a little bit less than the 4 hydrogen atoms that went in. A tiny, almost invisible fraction of mass just vanishes. But it doesn't really vanish. It turns into pure, raw energy. You've seen the equation your whole life. On t-shirts, in movies, on classroom posters. EMC². But most people never stop to realize what it's actually describing. It's describing this. Right here, inside the sun. That equation isn't a math lesson, it's the instruction manual for how stars work. Einstein figured it out in 1905, sitting at a patent office desk in Switzerland. and he probably didn't even fully realize he was writing down the secret of every star in the universe. Here's what that equation really means, in plain English. Even the tiniest pinch of matter, if you could somehow convert it completely, contains an unthinkable amount of energy, because the speed of light is such a staggeringly enormous number, and you're squaring it. A speck of dust holds more energy than a stick of dynamite. That's what's happening in the sun's core, right now. As you're listening to this, every single second, the sun is converting about 600 million tons of hydrogen into helium. And 4 million tons of that mass disappears entirely, transforming into pure energy. Stop and think about that for a moment. 4 million tons of matter. Gone. Every second. Turned into light. Turned into heat. Turned into the same sunlight that warms your coffee cup in the morning. The same light you've stepped outside to feel on your shoulders every day of your life, without ever once thinking about where it actually came from. Now, here's where it gets really wild. The energy released in this reaction is so enormous that if you could somehow capture just 1 second of the sun's output, it would be more than humanity has used in our entire history combined. Every car ever driven, every factory ever built, every light bulb, every computer, every rocket, every refrigerator, every power plant on the planet, every barrel of oil ever pumped out of the ground, every coal mine, every dam, every nuclear reactor we've ever built. All of it, every bit of energy our civilization has ever produced, the sun beats that. In a single second, then it does it again the next second, and the next, and it's been doing this, without a single break, without a single pause, for 4.5 billion years. Before Earth had oceans, before life existed, before the dinosaurs, before the continents were even shaped the way you know them on a map, the sun was already doing this every second. So when scientists say the sun is exploding, they don't mean it as a metaphor. They mean it quite literally. It's the equivalent of billions of hydrogen bombs going off every second inside its core. If you lined up every nuclear weapon ever built by every country on Earth, every warhead from the Cold War, every Soviet stockpile, every American silo, every test in the Pacific, and detonated them all at once, it wouldn't even register. Not a blip, not a flicker. The sun does more than that in the time it takes you to blink. That is what's hanging in our sky. That is what we casually call sunlight, and yet, here's the thing that should stop you in your tracks. The sun isn't getting bigger. It's not collapsing. It's not shaking itself apart. It's not even flickering. You look up today, and it looks exactly the same as it did when you were a kid riding your bike in the summer. The same as it did when your father was your age. The same as it did when your grandfather was a boy. The same as it did when the pyramids were being built. The same as it did when the very first humans walked out of Africa and looked up at the sky, squinting, wondering what that bright thing was. How is that even possible? How can something exploding with that much force, that constantly, that violently, just sit there, calmly, steadily, reliably, like an old friend? Think about what normally happens when something explodes. A grenade, a stick of dynamite, a controlled demolition of an old building, the kind you've seen on the news, where they implode an old stadium and it collapses in on itself in a cloud of dust. The energy rushes outward, the structure fails. It's all over in seconds. That's what explosions do. They destroy themselves in the act of exploding, but the sun doesn't. The sun keeps exploding, and keeps going, and keeps holding its shape, a perfect, almost eerily perfect, glowing sphere, for billions of years. Something is stopping it from flying apart. Something is holding all that chaos together. Some invisible force is keeping every one of those countless atomic reactions contained inside a ball that hasn't changed in any meaningful way since before life crawled out of the oceans. And this is the part that makes physicists stop and just marvel, because the answer is subtle and strange and honestly kind of beautiful, There's a cosmic tug-of-war happening inside the sun. Right this very moment. As you're listening to this, two forces, both unimaginably powerful, are locked against each other. One of them is trying to rip the sun apart. The other is trying to crush it into nothing. And somehow, through some delicate, silent, ongoing act of cosmic balance, they're matched, almost perfectly, to an accuracy that would make the finest Swiss watchmaker weep. If that balance tipped even slightly in one direction, the sun would swell up and swallow the inner planets. Mercury, Venus, and yes, Earth. Everything you've ever known. Gone in an instant. If it tipped the other way, the sun would collapse in on itself and blink out. The sky would go dark, the temperature on Earth would plunge, and every living thing on this planet would be gone within weeks. Neither has happened, not once, not in 4.5 billion years. This silent, invisible standoff has been going on the entire time life has existed on this planet. Through every ice age, every extinction, every war, every empire that rose and fell, every person who was ever born, lived their life and passed on, the whole time, right above their heads, this impossible balance was holding, and it's still holding right now, quietly, above your head, without you ever needing to think about it. So what are these two forces? What exactly is holding this monster in check? And how is it possible that we're sitting just 93 million miles away from something this violent? And yet almost none of that violence ever reaches us. To really understand that, we have to zoom in on something you can't see, something you can't feel, something so small that for most of human history, we didn't even know it existed. But it's the only reason you're alive to hear this story at all. That invisible standoff, the one keeping the sun from tearing itself apart, the one keeping you alive without you ever knowing it existed. Let me show you exactly what it looks like. Imagine you could survive inside the sun, just for a second. You wouldn't burn. You wouldn't vaporize. You'd just float there, halfway between the core and the surface, looking around at the chaos. And the first thing you'd feel isn't the heat, it's the pull. Something tugging on you, hard. Harder than anything you've ever felt in your life. It's gravity. But not the gentle gravity you're used to here on Earth, the kind that just keeps your coffee cup from floating off the kitchen table. No, this is gravity on a completely different scale. The sun is so massive, so unbelievably heavy, that its own gravitational pull is trying every single second to crush it into a tiny point. A point smaller than a city, smaller than a house, smaller than anything you could picture. That's the first force. Gravity pulling inward, trying to collapse the entire star under its own weight. And it never rests. It never slows down. It never takes a break. For 4.5 billion years, this inward crushing force has been squeezing every atom of the sun toward the center with a grip that's almost impossible to comprehend. Now look back toward the core, because there's another force working against gravity. And this one is trying to do the exact opposite. It's trying to blow the sun apart, rip it to pieces, tear it open from the inside. This is the force coming out of the fusion reactions we talked about earlier. All those hydrogen atoms smashing together, all that mass turning into energy, all that heat and light and pressure building up in the core. That energy has to go somewhere. It can't just sit there. So it pushes outward, violently, with unimaginable power. It's like a furnace inside a sealed vault, constantly trying to burst the doors open. And here's where the beauty kicks in. These two forces, gravity pulling in, pressure pushing out, are matched. Almost perfectly. Not approximately, not roughly, almost perfectly. Every layer of the sun, from the core all the way out to the surface, sits in this invisible, silent standoff. The inward pull at any given point is almost exactly cancelled by the outward push at that same point. And that's why the sun doesn't collapse. That's why it doesn't explode outward. It just sits there, glowing, for billions of years, because the two most violent forces in its body have agreed, somehow, to hold each other in place. Scientists have a name for this balance, but forget the name for a second. Just picture it. Imagine a balloon being squeezed from the outside by a giant invisible hand, while at the same time, air is being pumped into it from the inside at the exact same rate. The balloon doesn't shrink. The balloon doesn't grow. It just stays the same shape. That is what the sun is doing right now. Every moment, every second. A cosmic balancing act so delicate and so precise that if you tipped it even slightly in one direction, the whole thing would unravel. And now here's the part that should make you lean forward, because this is where it gets really strange. That energy being produced in the sun's core, the raw heat and light from those fusion reactions, doesn't just shoot out of the sun like a beam of sunlight. It has to travel. It has to get from the center of the sun all the way to the surface before it can escape into space. And you'd think, given how fast light is, that this journey would take basically no time at all. Light travels at 186,000 miles per second. The radius of the sun is only about 432,000 miles. So a photon should be able to make that trip in a little over 2 seconds, right? Just a blink, just a heartbeat. But that's not what happens, not even close. A photon born in the core of the sun doesn't travel in a straight line. It can't. The interior of the sun is so unbelievably dense, so crammed with particles, that the photon can't go more than a tiny fraction of a millimeter before it crashes into something. An electron, an atom, another particle, and when it crashes, it gets absorbed. A moment later, that particle releases a new photon, but in a totally random direction. Could be forward, could be backward, could be sideways, doesn't matter. The photon is now going a different way. And then it slams into the next particle, and the whole thing happens again, and again, and again. So instead of flying straight out of the sun in 2 seconds, a photon stumbles through the core, bouncing around like a pinball in the most crowded pinball machine ever built. Drunk, lost, wandering. For how long, do you think? A minute? An hour? A year? Try this. The best estimates say about 100,000 years. Some scientists think it could be closer to 1 million. Let that sink in for a second. The sunlight warming your face at this exact moment, the light that just bounced off the kitchen wall, the glow coming through your window on a Sunday afternoon, began its journey inside the sun long before humans invented writing, before the pyramids, before agriculture, before civilization of any kind. The photons hitting your skin today were born in the sun's core back when woolly mammoths still walked the earth. That is almost impossible to wrap your head around. Your sunlight is ancient. It's older than every human story ever told, and it spent almost all of its existence trapped, bouncing, struggling to escape. Only in the last 8 minutes of its tremendously long life did it finally break free of the sun's surface, shoot across 93 million miles of empty space and land on your face. Now. Okay. The photon finally escapes. It's free. It races out into the darkness of space at the full speed of light. And here's where the next puzzle begins, because even after all of that, we're still sitting 93 million miles away from a nuclear furnace that's exploding with the force of billions of hydrogen bombs every second. And yet somehow, we're not cooked. We're not vaporized. We're not even uncomfortable most of the time. You can walk outside on a summer afternoon, feel the sun on your skin, and it just feels pleasant. How? The first answer is distance. And distance is one of those things that sounds too simple to be powerful. But it's actually one of the most powerful shields in the universe. Here's the thing about energy spreading out into space. As you get farther from a source of light, that light doesn't just get a little weaker. It gets dramatically weaker. If you double your distance from the sun, you don't get half the energy. You get a quarter of the energy, triple the distance, and you get a ninth. The intensity drops off fast, much faster than you'd expect. Earth is sitting in a cosmic sweet spot, far enough from the sun that most of that staggering energy has already spread itself thin across billions of cubic miles of empty space before it ever reaches us. If we were just a little closer like Venus, the heat would be unbearable. If we were a little farther like Mars, the planet would be a frozen desert. We landed in exactly the right spot. Not by luck exactly, but it sure feels that way when you really think about it. Think about the last time you stood outside on a warm day. Maybe in your own backyard. Maybe on a beach, somewhere you loved. Maybe just stepping out to get the morning paper, you felt comfortable. Safe. The warmth on your shoulders, the light on your face. And you had no idea that 4 invisible things had to go right for that single moment to even be possible. That's right. 4. Because distance alone isn't enough. The sun isn't just sending us comfortable, cozy sunlight. It's sending us a lot of other stuff, too. Invisible stuff. Dangerous stuff. Streams of charged particles flying out from its surface at hundreds of miles per second. High-energy radiation. Cosmic particles that could rip through your DNA like bullets through paper. If you were floating in space, unprotected, even at Earth's distance from the sun, you wouldn't last long. The radiation alone would destroy you. So what's saving us? 2 more invisible shields. And they're both sitting right above your head right now, working overtime, protecting you from a universe that is far more hostile than it looks. The first one is Earth's magnetic field. Our planet has this incredible, invisible bubble around it, generated by the liquid iron swirling deep inside our core. You can't see it, you can't feel it, but it extends tens of thousands of miles out into space. And when those deadly charged particles from the sun come racing toward Earth, most of them don't just slam into us. They hit this magnetic bubble and get deflected. They get pushed around the planet. They get funneled toward the poles. If you've ever seen photos or videos of the northern lights, that shimmering green and purple glow dancing across the Arctic sky, that is literally solar particles being steered by our magnetic field, slamming into the upper atmosphere and releasing their energy as light. What looks like one of the most beautiful sights in nature is actually the Earth deflecting a bullet. Every single night the auroras dance, we are watching our planet defend itself in real time. The second shield is the atmosphere. That thin layer of air above your head, the stuff you breathe without thinking, is doing something absolutely miraculous. It's absorbing radiation. Ultraviolet rays that would burn your skin off in minutes, gamma rays, X-rays. Most of the dangerous parts of sunlight, the atmosphere soaks them up before they ever reach the ground. The ozone layer, in particular, the thin sheet of molecules high above us, is like a built-in sunblock for the entire planet. It takes the sun's most violent radiation and absorbs it, breaks it down, scatters it, so that by the time sunlight actually reaches your skin, it's been filtered, softened, gentled into something your body can handle. And now when you put it all together, something kind of breathtaking comes into focus. There are not 1, not 2, but 4 different invisible defenses protecting you from the sun's fury. First, the sun itself has that inner balance keeping it from blowing up. Second, the sheer distance between us thins out the energy. Third, Earth's magnetic field deflects most of the dangerous particles. Fourth, the atmosphere absorbs the harmful radiation that gets through. 4 silent, invisible layers of cosmic armor, all working at once, all the time, all for you. You've never had to think about any of it. You've never had to thank them. You've never even noticed them. And yet, the reason you're alive, the reason you can sit on a porch and feel warm sunlight and call it peaceful, is because these 4 defenses are, at this very moment, doing their job perfectly. But here's where the story takes a darker turn. Because the sun doesn't always play by the rules. Most of the time, it hums along at a steady pace, glowing calmly, sending out its usual stream of light and particles. But every so often, without much warning, the sun loses its temper. It builds up too much magnetic tension on its surface. It twists and coils energy in knots that get tighter and tighter, like a rubber band being wound up too far, and then, in a flash, it snaps. A sudden, explosive release of energy that launches billions of tons of charged plasma out into space at millions of miles per hour. When that happens, our 4 invisible shields are suddenly not quite as invincible as they seemed. Power grids can go down, satellites can fry, entire continents can flicker into darkness. Astronauts in orbit can be exposed to lethal doses of radiation. The fragile balance that has protected us for billions of years can be tested in ways that would shock most people. And it has happened before. It happened in 1859. It happened again in 1989. And most folks watching this right now have no idea how close we came. Or how easily it could happen again. The next time the sun loses its temper like that, it could push modern civilization back 100 years in a single afternoon. In fact, it already has. It's a calm September night in 1859. You're standing outside, maybe on a quiet farm somewhere in the American heartland, maybe in a small town in the Caribbean. The air is cool, the stars are out, and then, without warning, the sky above you starts to glow, not softly, not gently. The entire sky lights up in shades of crimson, green, and gold. So bright that people wake up thinking the sun is rising in the middle of the night. Birds start singing. Miners in the Rocky Mountains get up and begin cooking breakfast. Convinced morning has arrived. In Cuba, people in the streets look up and see the sky bleeding red. Some drop to their knees. Others think the world is ending. And in telegraph offices across America and Europe, something even stranger is happening. The wires are sparking. Paper is catching fire on the desks. Operators are getting electric shocks through their equipment. Some telegraph machines disconnect their batteries entirely, and the lines still keep sending messages on their own, powered by something invisible in the air. Nobody on Earth could have known what was happening, but what they were witnessing was the aftermath of the most violent solar storm in recorded human history. We call it the Carrington Event, named after the British astronomer who saw the flash on the sun's surface a day earlier. He was sketching sunspots through his telescope when, for 5 minutes, 2 blinding points of white light erupted from the sun's face. He didn't know it yet, but he was watching the sun snap one of its own magnetic lines, launching billions of tons of charged plasma directly toward Earth at millions of miles per hour. Here's what happened inside that storm. The sun's magnetic field, those invisible lines of force that run across its surface, had gotten tangled into a twisted knot. Coiled tighter and tighter, like an overstretched rubber band wound past its limit, and then it snapped. All at once, a coronal mass ejection, a wall of solar fury, invisible and silent, hurtling through the darkness of space until it slammed straight into our magnetic shield. And our shield held. Mostly. The aurora that night was the result. Our planet absorbing the blow, converting destruction into light. But the storm was so powerful that some of that energy leaked through. It surged through the only electrical system humanity had at the time, telegraph wires, and set them on fire. That was 1859. A world lit by oil lamps and connected by copper wire. A world where most people never touched anything electrical in their entire lives. They survived it. Barely noticed, honestly, beyond the strange lights in the sky and some ruined telegraph machines. Now imagine what would happen if the exact same storm hit the Earth today. Really think about it. Our entire civilization runs on electricity. Not just some of it. All of it. Every light in your home. Every refrigerator keeping your food from spoiling. Every hospital keeping patients alive. Every traffic light. Every bank. Every cell tower. Every computer. Every satellite orbiting above your head. Every GPS system guiding every airplane in the sky. Every piece of our modern world is wired into one enormous, delicate, interconnected electrical grid that stretches across continents. A Carrington-level storm hitting today would overload transformers across entire countries in a matter of minutes. Not hours, minutes. Power could go out, not for a day, not for a week, but for months. Some estimates say the largest transformers, the ones that take years to manufacture and ship, could take 2 to 4 years to replace. Satellites would fry. GPS would vanish. Airplanes would lose navigation. Hospitals would run on backup generators until the fuel ran out. The global economy could lose trillions of dollars in a single week. And life as we know it, the smooth, humming background of modern civilization that you and I take for granted every single morning, would grind to a halt. That's not science fiction. That's not a movie. That's what the National Academy of Sciences published in a report in 2008. That's what NASA has warned about. Repeatedly. And here's the part that should genuinely unsettle you. In July 2012, the Sun fired off a coronal mass ejection just as powerful as the one in 1859. Just as fast, just as violent, it ripped through the exact stretch of space where Earth had been just 9 days earlier. 9 days. If our planet had been a little further along in its orbit, if we'd been 9 days ahead in our 365-day trip around the Sun, you would remember 2012 very differently. We all would. Nobody really talks about it. It barely made the news. But we came that close. 9 days between ordinary life and a world none of us would recognize. And yet, and this is the part that quietly takes your breath away, most of the time these storms don't reach us. Space is almost unimaginably empty. Earth is a tiny blue marble floating in a vast black ocean. The Sun can throw a coronal mass ejection in any direction, and the overwhelming likelihood is that it flies off into the void and never touches anything at all. It's like standing in the middle of a football field while someone throws a dart from the parking lot. The odds of getting hit are vanishingly small. Not zero, but small. And when one does aim our way, our invisible shields step in. That magnetic field you've never seen wraps around the planet and pushes the danger aside. That atmosphere you've always breathed filters out the poison. They catch the blow. They steer the deadly particles toward the poles. And instead of destruction, we get the northern lights. Instead of a weapon, we get a painting across the sky. Think about that. The most beautiful light show nature ever puts on, that shimmering, dancing curtain of green and purple across the Arctic, is literally our planet absorbing a punch in real time. Every aurora is Earth quietly defending itself. Every glowing arc is a reminder that something unseen is standing between you and the dark. And now, if you zoom all the way out, if you step back from all the numbers and the physics and the history, something breathtaking comes into focus. Not a new fact, not a new number, just a feeling. The feeling that you've been held your entire life. That something has been standing between you and disaster every second of every day, and you never once had to ask it to. You never signed up for this protection. You never earned it. It was just there. From the day you were born. Silent, patient, constant, the gravity and pressure inside the Sun perfectly matched, keeping our star from destroying itself. The distance between us, just right. The magnetic field around our planet, just strong enough. The atmosphere above us, just thick enough. Not designed, not planned, just balanced. For 4.5 billion years. And you, standing on a porch somewhere, watching the sunset, feeling warmth on your face. That warmth is ancient. Those photons began their journey inside the Sun's core hundreds of thousands of years ago. They bounced through layers of fire and chaos for longer than human civilization has existed. They finally broke free of the Sun's surface just 8 minutes ago. They crossed 93 million miles of cold, empty space. They slipped past the magnetic field. They filtered through the atmosphere. And they landed softly, gently, on your skin. That is not just sunlight. That is a journey older than any story your grandparents ever told you. Older than every language ever spoken. Older than every empire that ever rose and fell. And it ended, quietly, right there on your face, on a regular Tuesday afternoon, while you weren't even thinking about it, so look up tomorrow. Just for a moment. And know that the soft light falling on your shoulders is the kindest, gentlest echo of something almost impossibly fierce, a quiet miracle you've been living inside your whole life, every sunrise, every sunset, every warm afternoon you've ever loved. All of it, a gift. From an explosion that somehow impossibly learned how to be gentle.